So before we really get started with this, um, I kind of told y'all last week this whole unit is going to be about solving quadratic equations, which again means finding x-intercepts of a parabola. There's different methods that we're going to use to do it. So I erased it already, but the first one we talk about is factoring. So that's one way to find the x-intercepts of a parabola. There are other ways to do it too. So for the rest of this week, I'm just going to be showing you different methods of finding the x-intercepts of a parabola, which again means solving a parabola. The one we're talking about today is using square roots. All right, so this is the second method that we're going to talk about in order to do that. Before we actually solve any quadratic equations, we need to talk about some stuff. There's going to be a lot up here on this slide. You don't have to write it all down. It's going to get posted on Google Classroom. Just some information for you. When we're using square roots, there's some fancy words that I'm going to start throwing around. The square root sign, the fancy math word for that, it's called a radical. I don't know why it's called a radical. Somebody back in the day saw the square root sign and said, man, radical. How radical? So they started calling it a radical. I don't know. So from here on out, if I say radical, I'm not talking about like a sweet, yeah, I am a 90s kid, but I'm not talking about the 90s. I'm not talking about like a sick kick flip on your skateboard or something like that. I'm talking about a square root sign, which is about as cool. We can agree. You know, I'm watching the Olympics all weekend. I'm seeing these people throw crazy, like, 720 flips flying through the air. That's pretty radical. But square root signs are also radical. So anyways, the square root sign is the radical. The thing inside of it, the number inside of it, we call that the radicand. Again, I don't know why that's what it's called, but that's what it's called, the radicand. Here's what we're going to need to do. We're going to have to take these things and simplify them a little bit, make them look a little less ugly, and we need to use perfect squares to do that. Okay? So again, you don't have to write all this down. I'm just giving you the information. Here's some numbers. We're going to square these numbers. You guys know what your square roots are? Perfect squares and square roots. Maybe you have them memorized. 1 and 2 are easy. What's 3 squared? What's 4 squared? Wait a minute. How come you're not doing 4 times 2? Because that's not what squaring means. You guys are smart. What's 5 squared? 6? 7? Oh, you're so smart. I'm going to add a couple other ones up here. I don't know. You know what 8 squared is? Or 9. 10 is easy. 100. Do you know what 11 is? Do you know what 12 is? Wow. Not too bad. So these are our perfect square numbers. We're going to use these things to simplify some stuff. It's not? No. Oh, of course. You think I would know what the problem is, you know? Yeah. All right. There's a rule that we need to use in order to do this. The rule is this. It's pretty straightforward. If you have a number inside of a square root and you rewrite that number, 500 and 100 times 5, those are the same thing, right? So I'm just taking 500. I'm rewriting it as some factors. That's all still underneath the square root. The rule is this. You can break that thing up into multiple things underneath their own square root. And that's fine. That's okay. Nothing wrong with that. And now if you look at these things one at a time, well, we know what the square root of 100 is. It's 10. But I don't know what the square root of 5 is. So I just leave it as the square root of 5. So technically, this and this are the same thing. They're the same number. If you put those in a calculator, you would get the same thing. 10 square root of 5 looks a little more manageable than the square root of 500, though. So this is kind of what we're doing in the first part today. All right, let me give you some examples of this. Let's say I have these. It tells me to simplify each radical expression. We need to use the perfect squares to help us do this. So I'm going to write them out again just so we have them. Perfect squares. We got 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. Those are all the perfect square numbers, right? So here's how I'm going to do this. Since it's a square root, I'm asking myself, is there a perfect square number that goes into 48? Yeah, what? 16? 16 times 3? 4 goes into 48 too, though, right? Take the biggest one that you can. So I'm asking myself, is there a perfect square that goes in to these numbers? And if there is, you want to take the bigger one. So B said 16 times 3. That's great. I can rewrite 48 as 16 times 3. Just 48 is 16 times 3. And if you don't know what number to use, just get out your calculator, start doing 48 divided by these numbers until one of them works. Okay, so you can always just do process of elimination with a calculator. So 16 times 3 is 48. I've just rewritten it. And now remember, that fancy rule that I showed you says that since these things are underneath the square root, I can split them up and write them underneath their own square root. So now it's the square root of 16 times the square root of 3. I just broke it up. Well, what's the square root of 16? 4. Do you know what the square root of 3 is? It's some ugly number. It exists, but it's some weird, gross number. So I don't want to deal with it. So I just leave it as the square root of 3. Weird. I mean, far be it from me to discriminate against numbers. There's no number discrimination in here. The square root of 3 is a number 2. So there it is, 4 square root of 3. Does this make a little bit of sense? Okay, let's do one more. 243, that's a bigger number. It might be harder to know off the top of your head what perfect squares go into 243. So if you don't know, just take 243, start dividing it by these numbers. 81 goes into 243? What is it? 81 times what? 81 times 3? So again, I mean, I probably could have thought of that if I thought about it for long enough, but I don't know that off the top of my head. So just get out your calculator, do 243 divided by 9, 16, 25, 36, whatever, until one of them works. Okay? And try to get the biggest one that you can. So we can rewrite this as 81 times 3, because 81 times 3 is just 243. And then the rule is that I can split that up. Square root of 81 times the square root of 3. What's the square root of 81? 9. Done. Just making a little bit of sense. Okay. Then try those ones on your own. Ooh, they're different. Uh-oh. Hey, don't let it freak you out. Don't let it freak you out. Try them, and then we'll talk about them. All right. Do you want to see both of these or just one of them? Both? Okay, let's do both. Here's the deal. I know that there's some weird stuff in front that really doesn't change much. So like this 1, 3 with the negative really doesn't do anything. It just hangs out in front. So just focus on square root of 147. We'll do that normally. Is there a perfect square that goes into 147? 49? 49 times what? 3? So it's negative Square root of 49 times 3. Remember, if you can't get those numbers, just do 147 divided by perfect squares until one of them works. Split it up. Notice how the negative sign is still just in front. Nothing changed. Square root of 49 is 7 root 3, and there's a negative in front. And that's it. That's all it is. The negative sign just stayed in front the whole time, didn't really do anything. Because it's a negative number. Yep. Don't let it scare you. It's just negative. Doesn't really change anything. Huh? Negative 3 with a square root of 7? Or negative 7 with a square root of 3? I don't know how you got that. Oh, so you did 7 times 21. The reason that doesn't work is because neither 7 or 21 are a perfect square. So you have to use a perfect square number. Okay? That's why we used 49, because it's a perfect square. All right? All right, let's do this one, and then you're going to do a checkpoint. There's a 3 in front, just like the negative sign. Ignore it for now. Let's just do this like we normally would. Is there a perfect square that goes into 150? What is it? 25 times 6. Okay, so it's the square root of 25 times 6. There's a 3 in front of that. Or the 3's not really doing anything, but it's just chilling. Split this up. 25, 6 underneath their own square root. What's the square root of 25? Okay, so it's 3 times 5 root 6. All right, now we can just multiply 3 times 5. And that is 15 root 6. And we're done. Capiche? The whole goal of this lesson was to learn how to solve a quadratic, find its x-intercepts using square roots. So we're actually going to do that now. We had to learn how to simplify some square roots, and that's what we were talking about at the beginning, because this is going to come up a lot. But now we can actually talk about solving these things. All right? So again, you don't have to write all this down. It says whenever the only variable we see is being squared, or as part of a quantity being squared, we can solve by taking a square root. So basically what that means is if there's only one x and it's getting squared, then we can use this method. So like in this example, there's only one x. In this example, there's only one x. If there's more than one x, this isn't going to work. But if there's one x, we can do this. All right, and here are the steps. First, we got to isolate the thing that's being squared. Take a square root of both sides. I'll tell you what this means in a second. And then solve the problem. So like I said, don't worry about writing all this stuff down. It's all going to get posted. Let's actually do an example. Let's do the important part. We got 5x squared plus 12 equals 72. So the first thing that you want to do is isolate the thing being squared. Isolate the thing that's getting squared. So I got x squared, right? So I need to get x squared alone. So what might you want to do? Okay. Minus 12, that'd get me 5x squared equals 60. Now what? Divide by 5. And I get x squared equals what? 12. All right, cool. We got the thing being squared by itself. X squared equals 12. Now, remember, I'm trying to get x. I don't want x squared, I want x. It's x squared. How do you undo squared? Square root. Take a square root of this. I got to take a square root of the other side as well, because whatever I do to one side, I also do to the other. Algebra 101. All right, so here's what this is going to look like. The square root of x squared is just x. The square root of 12. Well, we can deal with that in a second. But before we deal with that, I got to point something out to you. And it's this thing. Remember plus and minus. Here's what that means. Anytime you take a square root when you're solving, you have to add what we call a plus minus. So it's not just the square root of 12, it's plus minus square root of 12. Because it can be positive or negative. Let me show you what I mean. If I asked you what the square root of 4 is, what would you say? 2. Because 2 times 2 is 4, right? Yeah. Negative 2 times negative 2 is also 4. So what does that mean? So the square root of 4 could be 2, and it is 2. Technically, negative 2 also works, because negative 2 times negative 2 is also 4. Does that make a little bit of sense? So anytime you take a square root, you need to account for the positive option as well as the negative option. So really what the plus minus is doing is it's giving you two numbers, positive square root of 12 and negative square root of 12. And that's all it is. Okay. What's that? Yes, now we're going to simplify it. Okay. So now I have the square root of 12. Are there perfect squares that go into 12? You always want to simplify it if you can. So we're going to simplify. Sure, 4 and 3. So it's the square root of 4 times 3. That's the square root of 4 times the square root of 3, which is 2 root 3, right? That's what we just spent time practicing. But don't forget it's plus minus. So your answer here is that x equals plus or minus the square root of 2 root 3. It could be positive 2 root 3. It could be negative 2 root 3. Just make a little bit of sense. Okay. Let's do one more, and then I'll turn you loose. Yep. Ready? All right. Let's do this one, and then you guys will be on your own. So again, first thing we want to do is get the thing that's being squared alone. Well, what's being squared in this one? This whole thing, x minus 4, this whole thing is being squared. So I need to get that thing alone. So first, I'll add 1. I get negative 2. So I add 1. Now what? This is where it gets a little weird. If you distribute, well, first off, it's this thing being squared, right? So you would need to square this first and then distribute it. We definitely don't want to do that. What do you think, Amelia? Yeah, just get rid of the negative 2. Undo it. It's getting multiplied, so just divide. You can divide this whole thing by negative 2. That's okay. It's just going to go away. So now I have x minus 4 squared equals positive 44. Is the thing being squared now by itself? Yeah. X minus 4, that quantity is being squared. So I can do what we did over here. Take a square root of both sides, and it's going to look like this. X minus 4 equals plus or minus the square root of 44. Yes? All right, real quick, let's just deal with the square root of 44. We're not quite done. Well, actually, let's do that in the end. Is x by itself? No. How do you get it by itself? Add 4. Remember, you want x alone. Do not, when you get to this point, I'm adding 4, do not turn this into the square root of 48. Because that's not what it is. The square root of 44 is like a number. And it's not 44, right? It's some weird decimal. So if you just turn this into the square root of 48, that's not how the numbers work. You can't just add this to the number underneath the square root. That's not how we do it. Okay? Here's how you're going to write it. Always have the plus minus in the middle. It's going to go like this. 4 plus or minus the square root of 44. So move that number over, keep the plus or minus in the middle, and we got our new quantity. Does that make a little bit of sense? All right, now let's simplify the square root of 44. We can deal with this thing now. I'm going to simplify square root of 44. Is there a perfect square that goes into 44? Sure, 4 and 11. Square root of 4 times 11. So what's this going to turn into? What's the square root of 4? 2. Is there a square root of 11? No. So there it is. So we can write our final answer like this. X equals 4 plus or minus 2 times the square root of 11. Done. Let's talk about them together real quick. First one, I'm going to run through these a little bit faster than normal. I would subtract 16. I'd get 3x squared equals what? 66. Is x by itself? No. What do you need to do to get it by itself? Okay, so now it's x squared equals 22. Take a square root. I have x equals square root of 22. Plus minus. You passed the test. Don't forget the plus minus. One-way ticket to Calcatraz. If you forget the plus minus, I'm shipping you off. To Calcatraz? Oh, well. Hey, you know what? In the high stakes world of mathematics law, I am the judge and the jury. I have full right to sentence somebody to Calcatraz or not. All right, here you go. Is there a perfect square that goes into 22? No. So can you simplify that? No. That's fine. That's your answer. If you can't simplify it, that's okay. All right, one more. Do we have questions on this at all? Okay, one more and then we're done. Got to subtract 8. That gets 100. Then what? Divide by 4. Guys, I just want to reiterate this one more time. Do not square this thing. Do not multiply it by 4. You're trying to get things to look more simple, not more complicated, right? If you square it, that's going to look really ugly. So don't do that. You're trying to make it look less ugly. Divide it by 4. That'll get rid of this. Now it's looking a little bit better. It's 2x minus 3 squared. What's 100 divided by 4? 25. Can you take a square root now? Yes. It is 2x minus 3 equals plus or minus. I'm just emphasizing the plus minus. What is the square root of 25? 5. All right, now this is looking a little bit different because I still don't have x, and I want it. I got to have it. I'm going to add 3. Remember, you can't just turn this in to 8. It's not just 5. It's minus 5 and 5. So you can't just turn this into 8. You're going to write it as 3 plus or minus 5. Remember, plus or minus always goes in the middle. Now, if we divide by 2, I'm going to divide this whole thing by 2. That's okay. So my answer looks like x equals 3 plus or minus 5 divided by 2. Now, I know that looks really, really weird. But just remember what the plus minus is. It's two numbers. And in a situation like this, we can actually go find those two numbers. So if you write it like this, I'm cool with that. I'm good with that. That's acceptable to me. But you could also go find the numbers. It is, let's call it x. What, if you want to say that, that's fine. 3 plus 5 divided by 2. And the second one is 3 minus 5 divided by 2. And these are pretty easy to find. 3 plus 5 is 8. And 8 divided by 2 is 4. 3 minus 5 is negative 2. Negative 2 divided by 2 is negative 1. So those are your x-intercepts. Again, if you left it like this, I'm cool with that. But you could also go find the numbers. Does this make a little bit of sense?